Okay, now let's use some trig and some problem solving skills for some bearing problems. All right, so here's example 4. Radar stations A and B are on the east-west line with A west of B. So if I'm looking at this east-west line, it's side to side, right? A is west of B. So I know those are on the horizontal. 3.70 kilometers apart. So this is 3.70 kilometers. Okay. So here's A and here's B. Okay. Station A detects a plane at point C on a bearing of 61 degrees. Station B, so if I'm looking at this bearing, so if I have a bearing, wait, here, let me try this, draw this again. This needs to be straight up here. So this is north. So if I'm going a bearing that's from here, this is 61 degrees. So that means 61.0 if I'm keeping my significant digits, right? 61.0 degrees, that means this out here is C. So if I'm looking at this, I'm going from that bearing of north. It's always a bearing from north. Station B simultaneously detects the plane on a bearing of 331. So that's the kicker to this. If I'm looking at a bearing is always going clockwise. So if I'm going to go 331, that's going to send me all the way back around here. So from here, oops, I need my pen. So from here up to here, this is 331 degrees. Do you see where I'm getting at? Okay, so if I'm talking about a bearing is always from north, and you're always going in that clockwise direction. The other kicker to this is A to north. I know this is always a 90-degree angle. So what I'm being charged with is finding the distance here from A to C. So I want to find this distance right here from A to C. My distance from A to C is going to be across from B. Now, if I know that I'm looking at these bearings that we have, then I have 29 degrees is over here. That doesn't look right. How do I know that? Yeah, so I know this makes a right angle. If this makes a right angle, in order to figure out these two angle measurements, then that's going to give me that 29 degrees. So I have 90 minus the 61, that'll be that 29 degrees, and that's where that's coming from up there. All right, now here's my next thing. What is this angle measurement? If I know this is going all the way up to 331 degrees, I got overzealous with this line there. If this is going up to 331 degrees in order to make that happen, then what is this missing angle measurement in here? Yes, 360 minus that 331, and that's how I get that value. So what would that give me? Good. So that in between there is going to be that 29 degrees. Right? Then what's the other one? 61, because it's still a complement. So if I know that this angle measurement is 29, this angle measurement is 61, what is reserved for this angle measurement? Yes, it is. And we just made a right triangle. Now I can use right triangle trigonometry. Oops. For this triangle here. If I want to figure out B, because it's across from that, then I can use some values. I know that I have an adjacent, I know I have a hypotenuse right here, and then across from that hypotenuse is going to be my opposite. So which trig am I going to use? Yes, so this ends up being the adjacent. Oh my gosh, why do I keep saying that? For the love of Pete. This is going to end up being my opposite. Oh my gosh. And this is the hypotenuse. So I know across from that, I'm going to end up with the cosine. Oh my gosh. Sine of B here is going to equal the opposite over the hypotenuse. So sine of 61 is equal to the opposite, which is that B value, over my hypotenuse, which is 3.70. So B in this instance will be 3.70 times the sine of 61. And then what's that going to get you? Yep. B is now equal to 3.24 or 3.236. However, I know that I'm looking for three figures here. Kilometers. What's another thing you could do? Which is what my head was doing while we were talking about this. I kept trying to make it cosine. How else could you work this? Yes. 29, you can make a cosine. That would be your adjacent, and then that would be your hypotenuse, right? So if I'm looking at B, B is going to be that. But if I have this angle A right here, I could do adjacent and hypotenuse, and I could use cosine. You're going to come up with the same thing. All right, so this is the beauty of this kind of problem, is you can literally do different ways in order to figure this out, and you're still going to get the same deal. However you work out your right triangle trigonometry. All right? Okay, so this is one way to do bearing. If I'm looking at this due north here, and then bearing off of north. Another way to do bearing is to look at it like southeast here, and you can look at these different values northeast. So it points you in the direction you need to go. If it simply says bearing, then you're coming off of north. But if it gives you these other values, then that's how you're finding it. Okay, so let's look at this one. The bearing from A to C, so here I have A. I'm going to push this kind of off to the side because we're going to have this north-south line. So this is A. Is going to be south 52 east. Okay, so that means from A here, this is south, right? This is south, this is north. East goes in this direction. So from south to east, I'm going 52 degrees. That's from A to C. So this is 52 degrees. Do you see that? So south to east is going to be 52 degrees. A bearing from A to B, so to come up to B somewhere, let's call this B, is going to be north, so it's got to go higher, north, and then east is going to be 84 degrees. To get here, from here to here, this will be 84 degrees from north to east, because I'm going north from up high to the east, which is then to the right. Okay, the bearing from B to C is going to be southwest. So again, on my B here, I've got my north-south line, and I'm going to go south, but then it's going to go west, which is going to be to the left. So southwest from here to here is 38 degrees. A plane flying at 250 miles per hour takes 2.4 hours to go from A to B. I want to find the distance from A to C. All right? Okay. So all this information, we're going to take this information in order to pull it off. But I want to point something out. The bearing situation, if you're given both directions, the north-south and the east-west direction, then that's how you set that up. Now here's the kicker. The whole purpose of this information is we know a little thing coming into this. Distance is equal to rate times time. So my rate here, the distance from A to B, because we don't have any distances. We're trying to figure all this stuff out, right? So my distance from A to B here is going to be 250 times this 2.4 hours. Oops. And that will be, if you plug that all in, 600 miles. So this is 600 miles. So now I have one bit of measurement there. But my goal here is to find the distance from A to C. This is what I'm actually trying to find. This distance here from A to C, which is little b again, because it's across from that. All right. So here's the kicker. When I'm looking at these values, I know that I have this line. This is 52, this is 84. Because this is 84 and this is 52, can you figure out what this one is? Yeah, those are called supplementary. Remember when we talked about those supplementary angles? So I have 180 minus that 84 minus that 52. And what do you end up with? 44. So I know that is 44 degrees. All right. And we also know that if you have two parallel lines cut by a transversal, so we're really getting our geometry going for us here, right? North, south, these are two parallel lines and they're cut right here. I know that this angle measurement is equivalent to this. I also know that this angle measurement is equivalent to this. So if I know that 84 is equal to 38 plus this, whatever that is, then that's how I get that angle measurement. Do you see what just happened? So this is geometry. So you may be looking at this going, what just happened? If you have two parallel lines, so here's just a little bit of geometry review for you. If you have two parallel lines cut by a transversal, so I'm going to make this a highlighter. Here's a parallel line, and it is cut by this transversal. This angle on top is equivalent to this angle. They're called alternate interior angles. Cool, right? So alternate interior angles are what we're going for there. So if I know that that is alternate interior, I now know that this is angle B. We're going to call it angle B. This is just my angle B here. I've got B is equal to 84 minus 38. So what is 84 minus 38? 46. If I know this is 44 degrees, this is 46 degrees, I can figure out this whole triangle right here. Yep, and it does end up being 90. Good. I can figure out this whole triangle because it's 180. If 44 plus 46 is 90, then I know this other angle is now a 90-degree angle, and now I can use right triangle trigonometry. The same thing is happening on this problem and the previous problem. You are not told up front, oh, this is right triangle trigonometry. Not every single triangle out there is a right triangle. You have to show that this is a right triangle. And as soon as you figure out that it's a right triangle, then you can start using your right triangle trig. So my goal here is still to find this side length. This is B. This is my goal of what we're trying to find, that distance from A to C. We've got lots of angles here. So if I'm looking at this, you can use cosine, adjacent over hypotenuse. Why not? We used sine on the last one. Let's use a little cosine here. So the cosine of 44 is going to equal that b over 600. So multiply both sides by 600, and b is going to actually equal 431.6 miles. What else could you have done? Sure, you could use this 46. You could do opposite here over the hypotenuse. You could have, yeah, that's the main thing. Because to get this, you could do sine for opposite. You could do the adjacent here with cosine of the 44. I don't really care about this one, so it doesn't matter what that is. All right? So use what you know. Go with what you know with your right triangle trigonometry. These